or in general. All right, here we go. Section 9.3. Why did I close the book? That was really smart, Jeff. I don't know. Section 9.3. Oh, here we go. 9.3, number 42. Oh, yeah. This is, I'm sorry. All right. So here we have a great example of the power reduction formulas, right? So I think, didn't we do, give me a second. I want to remember what I did with you last time. Where was that? I thought for sure we did a fourth power one. Maybe I don't remember now. I thought for sure we did a fourth. Was it in here? Maybe it was in here. Because where's the power reduction stuff here? Here we go. The reduction formulas here. And here it is. This is the one we did. Cosine, we did cosine to the fourth power. So are you guys all with me? So somebody's asking about number 42. 42 has got a sine fourth power and a cosine squared. So the cosine squared is pretty easy to handle, right? There's a formula directly for cosine squared. Sine to the fourth, you write as sine squared, sine squared. Are you with me out there? So you got cosine squared times sine squared times sine squared. So you have cosine squared times sine squared times sine squared. Bam, bam, bam. Give me a sign here. Is that making sense? Or I'm sorry, if you're chatting at me, no, there's nothing. I've got nothing happening. Okay. And then you just have to brute force it out. So let me remind you guys. So the problem originally was cosine squared sine to the fourth, which is cosine squared, sine squared, sine squared. So the way I would do this is there's going to be a 1 over 2, a 1 over 2, and another 1 over 2. There's a total of 1 over 8 times this is in for cosine squared. And then I get 2 of these for the sine squares. I don't know why they have to do that. Oh, well, too bad. Right, so you got to multiply this out. Bam, 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 bam. Take the result and multiply it out with here. Bam, 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 bam. Multiply, multiply. Oh, this problem is going to be awesome. It's going to be like rolling a boulder up a hill and then it rolls back down. You got to roll it back up the hill. Who was that? Can't remember what Greek person that was. No, yes, maybe. It's not hard. It's just a brute force problem. You just do it. No good.
So you just keep multiplying it into each other, basically. Okay.
And when you multiply, you're going to pick up another cosine squared and a cosine cubed, right?
Mm-hmm.
So then you're going to have to.
Okay, cool. Yeah, that's where I'm at, the multiplying part.
Okay. All right. You just have to do stuff with it. You just got to tear it apart. You're tearing me apart. Okay. Anybody else? Anything else, guys? You doing okay? Are you guys doing okay? No. I'm sorry. There's 12 of us here tonight. Little group. All right. Hey, there's a person. Look at that. Oh my God. I'm so excited. Anything else from homework stuff or from the quiz? Anything? No, I lost somebody. Damn. has anybody noticed that I updated the homework timeline sheet? That happened earlier today. Let me see, hold on. Here we go. So this is brand new from today, part 2 updated. So I think I just changed the dates on a couple things. Okay. We're still pretty much on track. I have an option back here. If we need to, I can make some of these sections extra credit if it comes down to it, but we'll see how we do. Okay, I've given us quite a bit of time to kind of like get through chapter 10. That's a decent amount of time there. So I think with that, I don't think it should take us longer than that to get through chapter 10. Okay. All right. If nobody has any more questions, maybe I'll ask a question for you. Let me see here. What looks weird in here? Here, let's try a problem out. Let's do this before we get into chapter 10. Well, here goes some people. All right, so before we get into chapter 10, let's, and notice something. They constantly want us to find from 0 to 2 pi, right? And I kind of showed you a more general way to answer these questions. Man, it's everywhere. Oh, here we go. Determine all solutions of the trig function. Okay. So when they say all solutions, that means you got to do that plus or minus 2 pi k stuff. Solve the equations algebraically, then the 0 to 2 pi thing. I hate that. All right. Anyway. Let's try a couple of these out, just so we remember how to do these. Look at 51 real quick. This might be one that I assigned, but who cares? Can somebody identify something weird about number 51?
It's supposed to be 1.
How do you mean it's supposed to be 1? What is sine squared x plus cosine squared? What is it, period? What just is it?
1.
1. Beautiful. It's 1. Not supposed to be, not could be, nothing. It's just 1. So does this equation have any answers?
No.
Yeah, the only way this equation can have answers is if 1 somehow equals 0. Do you guys understand that? That's a weird one because you look at it, hopefully it looks weird. Some people don't even realize this is an identity and they start trying to do stuff. I'm like, no, that is 1. And so there's no solution. Okay, so that's a little bit of a weird one. You got to watch out for those. How would you do 52? What's the biggest problem with number 52? Trying to solve. Can somebody identify the issue with 52? It's pretty much in your face there.
How do you call it? Like you use identity.
Why?
Because you can subtract sine of 2x minus sine of x.
These are fundamental. You can't subtract sine x minus cosine x either, but I wouldn't have to use an identity on that equation. Right? So one of the biggest problems is I'm trying to solve for angles. And if the angles are not referencing the same thing, that is huge. That's a big problem to immediately take care of because they can't even agree on what their inputs are. So what can I do with sine 2x? Somebody else tell me. What can I do with sine 2x? How can I rewrite that? What is sine of 2x?
Sine x plus sine x.
No. Come on. Sine x plus sine x. How many sine x's are there? Sine x plus sine x. How many sine x's do you see?
2 sine x.
I see 2 sine x's. Why would this affect the inside, right? Do we have, like Rio said, do we have an identity that deals with double angles?
2 sine of x times cosine of x.
Yes. All right. So let me take a minute. Hold on. So everybody, there is really nothing wrong with, stay with me now. Stay with me. There's nothing wrong with when we are sitting here or when you're doing your homework. This one right here, this is huge. If you haven't printed this out for yourself, I don't understand you. This is insane. This is insane. This is insane right here. If you have not printed this out, you make less than no sense to me. There is nothing wrong with having this sitting next to you as we're discussing things, as you're doing homework. At the same time, though, you've got to get this in your brain. You must memorize everything up here. Either memorize it or come up with a method to remember it. I've tried to give you several that I personally use. The stuff down here you don't have to memorize, but it's still good to have this sheet sitting next to you because these kind of things do come up in the homework. Are you guys understanding what's happening? Is that okay? So if you have this sitting next to you while we have, you could just kind of find this and tell me, oh yeah, there you go. And that's fine because you're not taking a quiz or a test right now. So who cares? But once the test or quiz comes, you better have this stuff memorized in your brain, in your head. I don't know why I have to make sure you're not memorizing it in your foot or something. I don't know. So let's come back to this. Look at 52 again. So I think Rio started telling us how to rewrite this. I can write this as 2 sine x cosine x minus sine x equals 0. Does somebody see something I can do there? And again, if you want to, you can call sine x a and cosine x b. So then this becomes 2ab minus a equals 0. You guys with me? If you want to, you don't need to. What can I do with this now?
Factor.
Yeah, I could take an a out. So then either a is 0 or 2b minus 1 is 0. So b is 1/2. Is that, that's not a big deal now, right? So this is a cool little trick. I hope you wouldn't necessarily, can you just see that there's a sign in both? So you could just take a sign out and then you're left with 2 cosine x minus 1, which will lead us to the same place we're about to be because a, I called a sine x. So sine x equals 0. Or b is cosine x equals 1/2. Now the book is being kind of generous a little bit in a way by telling you to focus on 0 to 2 pi, so you don't have to do the plus or minus 2 pi k thing. Oh well. Well, what's the answer? Where's sine equal to 0? On 0 to 2 pi, where's sine equal to 0?
0 or pi.
0 pi. All right, now somebody else tell me, where does cosine equal 1/2? What angles does cosine equal 1/2 at?
Pi over 3.
Good. So pi over 3 or
5 pi over 3.
good. Down here, 5 pi over 3. So then there's all your answers. Now, if you're sitting there right now, staring at your screen, hating me with all of your might, I don't know what's happening over there. That's what I kind of envision in my head, is like you're looking at the screen saying, I hate you. What are you doing to me? All right. Hopefully that's not true. But I don't know. I'm getting so little from you guys right now. We need to work together on this shit, right? This is stuff you got to be able to do. I'm here to help you be able to do it. And I can't do that without anything, without getting anything. So I need something. I need somebody to say, I have no idea what any of this is. I need somebody to say, I can't memorize any of that stuff, Jeff. My God. Something, right? Are you guys there? Anybody? Any thoughts? Well, how are you guys doing? Are you just not feeling like? Julia says he's doing fine. Okay.
So could the x be 0 pi over 3 pi over 3?
Yep. This constitutes all of the answers. Exactly.
Okay.
Because they focused on 0 to 2 pi like that. Yeah. Okay. So let's see. Did I miss anything in there? Okay. So I feel like maybe, all right, so I'm almost certain that not a lot of people have gotten into section 9.5 yet. Because I haven't gotten a lot of chapter 9 stuff turned in yet. So that part's not horrible because you still have time to do this work. So hopefully you're doing fine in whatever section you're actually currently in. Okay, let me see. Let me try this one more time. Let's see what happens. Let's see if there's something else fundamentally. Yeah, all right, now stay with me. This is interesting. Let's see if you guys agree with me. Look at number 62. 62 is exceptionally freaky, all right? Maybe if I just tell you straight out, it's weird as shit, all right? Somebody I haven't heard from yet. Can you tell me fundamentally what is wrong with that equation? Why is that equation more difficult than the other ones we looked at? What do I need to address immediately?
The 8?
Okay, I can see why you might think that because it doesn't have a trig function attached, but no. Like, why is 60? Look at number 60. Do you guys remember how would I do number 60? 60 and 62 are different, but they look like they almost are the same. They want to be the same, but they're different. Anybody remember how do I do this? Do you see how these are the same idea? Can you factor this? All day long. I need factors of 8 that add to be 6.
Or x, 2x.
And of course, 1 times 1 makes 1. That's neat. Are you guys with me? So factoring is beautiful. Why does factoring work there? Because what did I assign x to be? What did x take the place of? With what I did right here. What did x take the place of? This is not a crazy question. What did x take the place of? You guys not want to tell me because it's too easy? And then you don't want to answer the hard question. Yeah, it took place of sine. It took place of sine. Can I do the same thing on number 62?
No, because cosine and sine are different.
Stupid cosine. So these are not based on the same thing. But I can, so what can I do? Somebody else. Is there anything that will help me rewrite this in terms of this to hopefully make it become a problem like this?
You use the identity.
Yes. Somebody else. Rio just helped you out. Which identity will I use? What connects cosine squared with some kind of sine? All right. Carolina. Do you know what's the first trig identity that we really talked about? The first trig identity, Pythagorean identity. What is it? Do you know?
Do I look at the paper with the trig that says the
Totally.
tangent?
You can. I said that a minute ago. Yes. So
Okay.
what is it? Sine squared plus.
Cosine squared equals 1.
Okay. So that means cosine squared equals, solve it for this, because that's what I want to replace, right?
1 minus sine.
Okay, I like it. I think I got enough of what you were saying before your connection got all weird. All right. So now I can take this, and in place of cosine squared, oops, let me take the equal 0 too. I can write 1 minus sine squared. Are y'all with me? This is not the hard part. So the hard part really, I guess, is it's not even that hard, but you got to know what to look for to tell you what to attack. These don't agree. That makes this problem not just hard, it makes it impossible. So the first thing to tackle is, can I rewrite this in terms of some kind of sign? Yes, I have a trig identity. So then look what happens here. I get 6 minus 6 sine squared. Now, let me see if you guys, all right, let's see what happens. So I get negative 6 sine squared plus 7 sine x. And then I put my 6 and my negative 8 together and get negative 2. And then I'm going to multiply both sides by a negative so that my first dude is not negative. Can you factor that now? And if you want to, you can always replace sine with a single letter. And this, does that look better to anybody? Better than this? I don't know. So how the hell are you going to factor this thing? Let's see. 6 times 2 is 12. Are some of you guys out there saying, this isn't good, man? You're talking about trig and you're bringing back all this factoring shit. Well, too bad. It can show up anytime it wants to. You got to know your factoring. Anybody help me out? What do you do with the 12 over here?
3 and 4.
3 and 4, I like it. And they both have to be negative. So you get that to be a negative 7 in the middle, right? So then, you take a 3u out, u minus 1, and I take a 2 out. You left a 2, Jeff. There you go, buddy. Take a negative 2 out, 2u minus 1. My God, I need some room. Erase this. And again, you don't have to put a u there if you don't really need to. Let me bring this up here. 3u minus 2 times 2u minus 1 equals 0. So u is 2/3 or u is 1/2. And then u were sine. So sine x equals 2/3. or sine x equals 1/2. Now look at this one. Is this one that we know the angle for? No. So that's one you can throw that in the calculator. You can do inverse sine of 2/3 and get whatever the hell that is, right? This is one you definitely should know the angle for. Do you guys understand what I'm saying? Does that make, do you see what's happening? So when is sine x equal 1/2? What angles does that work for?
Pi over 6.
Yeah, pi over 6 and
Minus pi over 6. No.
no.
Minus 5 pi over
No,
6.
no minus. But yeah, it's 5 pi over 6, yeah, so not negative, yeah. Okay. So you have to identify when it's something you can just do and when it's something you have to throw into the graphing into the calculator to figure out. You have to know which angles, which values you have memorized. All right. I'm going to erase all this and show you
I
something
have a
real.
question.
Yeah.
So for the inverse sine,
Yeah. Let me erase some of this stuff so we can talk about that.
Okay.
Because for this answer, hold on. Let me get all this stuff out of here. For this answer here, there was one in the first quadrant and one in the second quadrant, right? So for this answer over here, it's going to be the same thing. Oh, there's a lot of chat happening. I can't keep up. I'm sorry, guys. Oh yeah, okay. I like it. Now, is that what's happening? You guys don't want to talk, you want to write? Okay. So this guy's got to work the same way. So one answer is going to be the inverse sine of 2/3. Now tell me this, how did we get, for this answer, there's pi over 6, and there must be the reference angle in the second quadrant, so we took pi minus pi over 6. So you get 5 pi over 6. Is everybody with me on that? Is that cool? Because then they would both have the same y piece, which is what sine's all about. So I do the exact same thing here. There's inverse sine of 2/3. And so what's the other one going to be? I do the exact same thing. The exact same thing. So what's this other one going to be? Oh, if there's people chatting at me, I'm definitely not going to see it. Okay. We got this one by doing pi minus the reference angle. So here's the reference angle. So I'm going to get this one by doing pi minus the reference angle. Same way. So just because it's an angle that we don't have memorized, or that it's an angle that's gross, doesn't mean it's going to work differently than any other angle would. Okay. All right, let me clear this away. Here it goes. All this is going to go away. Here it goes. Clear. Can somebody tell me without doing any work what the answer is to that? So help me out, guys. What's the biggest sine can be? What's the biggest output for sine? Oh shit, is somebody chatting? Yeah, 1. Are you guys, I don't know. Is everybody okay? What the hell's happening? The biggest output for sine is 1. And the biggest negative output is -1. So can somebody tell me what's wrong with this equation? Why does this equation have no solution?
It's bigger than 1.
Yeah, you can't have a sine with an output bigger than 1 because we just said. We know that the biggest output sine can have is 1. No matter what you do, there's no way to make the output of sine bigger than 1. And don't tell me, well, you can multiply it by 3. Well, then you multiply by 3. It's not sine anymore. It's 3 times sine. So there's nothing you can do. There's nothing you can put inside here that's going to make the output bigger than 1. Is that right? We've known that for a while because it's based on the unit circle. And if I don't break up the radius at all, it's 1. And then sine and cosine are like little pieces of the radius. They can never be more than 1 then. Okay, maybe. So if you factor something and it says like sine x equals 1/2 or sine x equals 3, you just go like that. Right? That's beautiful. Don't waste any time. There's no solution to that. That can't happen. And that's this kind of thing is going to occur in the homework. It will. There will be situations where sine or cosine equals something bigger than 1 or less than -1. That's fantastic. No solution. Cross through that thing. Yay, less work. All right. All right. Let me delete this here. Bam. Okay. All right. So you guys have desperately got to do more chapter 9 homework so you have more questions ready. We're going to go ahead and start to get into chapter 10. And if you think I'm moving too fast, then why aren't you asking questions? What we're going to get into, and what I'm going to prove to you, first off, is the law of sines. And the law of sines and the law of cosines extends trigonometric concepts to non-right triangles. So it kind of makes sense. Like trig is based on right triangles. You guys agree with me? Pythagorean theorem is based on a right triangle, period. So what we're going to do is we're going to try to, if I'm given a triangle that has no right angles in it, I can create a right angle in it. So let's do that first. Let's do that, and then I'll show you where that leads us. Oh, let's see here. I have all this written down ahead of time. All right, here we go. Let me stop sharing. I'm going to do this up on the board. Oh, I got a chat. Okay, thank you. All right. I desperately need a professional to cut my hair. All right. This to me is some of the coolest shit. Law of sines is a neat little dude. All right, let me see if I can get my house straight here. Okay. Is that better? Yeah. Okay. So now watch. Let's see. I want to draw this all right, decently here. All right, let's say I have a triangle. It's obviously not, shit, that does look like a right angle. You can do it, Jeff. Let's see. That wasn't a right angle. You could have just said it wasn't a right angle, Jeff. I know. Let's make it a little more extreme. All right. That's definitely not a right angle. There's no right angles in this thing at all. But let's give this some names here. Let's call this B, A, and C. I'll call this angle A, angle B, angle C. Okay. Nothing too amazing happening yet. How do I create a right triangle or, a couple right triangles? All I have to do is drawing a height. Didn't I make a couple of right triangles, right? Okay. Now, watch this. Can somebody come up with an expression for H? Do you see how it's a part of two right triangles? Do you guys see that? So like it's a part of this little right triangle, it's part of this big kind of big nose right triangle, right? How do I come up with an expression for H? Let's say this little triangle here. What trig function would relate? In fact, let me call, that's true. I don't need that. We can do this. Come on, you can do this. What trig function will relate H and B in angle A?
Sine.
Sine. Okay. All right. Rio is definitely with me there. All right. So sine of A. Somebody else tell me what's sine of A? All right. So I see in the chat. All right. So isn't H B times sine A, right? Nothing amazing there. And remember, I told you guys a while back, this isn't exactly correct, and it doesn't matter. It's just a way of looking at things to remember. Sine A is the percentage of B that runs along the y direction. So H equals B times sine A. That's a way to kind of bypass this to go straight here. Now, you guys do the same thing we just did, but do it for this triangle. Or you can go straight to this. So what is the sine of B? What's the ratio?
H over A.
Yeah, H over A, I like it. Therefore, H is A sine B. Now, if H is B times sine A, and H is A times sine B, what does that mean about these? Anybody? Nobody? If
No.
H equals this and H equals this, how do these two relate?
Equal.
They're equal to each other, right? So B sine A equals A sine B. And there's a few different ways I can write this, but I can divide by A and divide by B. So I get sine A over A equals sine B over B. All right, so let me write this up in the corner. Now, what I'm about to do is going to be a little tricky with the way I've drawn this crazy ass triangle, but I'm going to do it. It's going to happen. All right, somehow. If I rotate this triangle, all right, let's see if this is going to work. Oh, okay. So I got B here. Well, let me give myself some more room. So I'm rotating this like this. So B is there, and then here's A. He's kind of long. And then, yeah. And then there's C. So I've rotated it there. Okay. Now here's where things get a little weird. Here's where things get weird. Let me see. Here's B, angle A, angle C. And now the height is going to be here. You guys with me out there? Have I completely freaked you out? Let me see. I'm drawing this a little bit shaky, but that's all right. There, I really want this to be a right angle. There we go. So I rotated this around. So all the sides, everything's the same. All the angles are the same. I've just rotated that triangle around. I want to make sure you understand I'm using the same triangle. Now, how can I write H? So I got this big right triangle here, correct? This big right triangle here, right? So what is H in terms of angle A and C?
Sine A.
Yeah, sine A
C,
equals
H over C.
H over C. So H equals C sine A. Now here's where you guys, all right, you ready? Oh boy. All right, let me get this a little bit better. That's angle C. It's supposed to be the capital letter. You're supposed to be the lowercase. All right, C's a hard one for lowercase. How about H in terms of angle C? This is where things get weird. All right.
Isn't it?
What's this? What's this right here?
A plus B.
Where are you hanging out at, A? Let's put you here. No, careful. It's not A plus C, no.
Oh, I said A plus B.
A plus B.
No.
No. Well, you have no idea. But I do know this is 180 minus C, correct? Anybody?
So isn't it could be A plus B? Because triangle is 180.
Oh, yeah. But that, all right, I'm not going to go there. Trust me. I see what you're saying now, Rio. That's not helpful. That's not going to get me anywhere good. But you're right. But it's not helpful. Now, well, let's see. A plus B does not equal C, though. So you're not quite. All right. Now, can I write? So the same idea. So what's sine of 180 minus C? Let me write that over here. What's sine of 180 minus C? For this triangle here, what's the hypotenuse?
A.
A. And you got this side, so it's going to be H over A. So you got H equals A sine of 180 degrees minus C. All right, now think about it. What's the sine of pi over 6? What's the sine of 30 degrees? Let me keep it in degrees. Why not? What's the sine of 30 degrees?
Half.
Yeah, 1/2. What's the sine of 180 minus 30? 150. Oops. So 180 minus 30. Come on.
Half.
The reference angle is the same. So what is it?
Half.
Half. So sine of some angle is equal to sine of 180 minus that angle? Okay, so how can I rewrite this? This is h equals a sine of c. It's supposed to be the higher uppercase c. Okay. All right, I don't know if you guys followed me on that. It's a little bit freakadelic, but not that big of a deal, dealing with reference angles. So now watch. This tells me that c sine a equals a sine c. Therefore, sine a over a equals sine c over c. But what else do we know about sine a over a? It freaking equals sine b over b, and it equals sine c. All right. So that is, if you've looked at that part of your, what do you call it? That trig laws sheet that I gave you, and the parts that you're supposed to memorize, that is sitting on the sheet, right? So we've just proven it. That's what we went through. All this beautiful torture here was proving this. I do want to point out one thing while I've got this picture here. And this one too, yeah, this is perfect. All right. What's the area of this? I'm sorry. What's up?
So is this the law of sines?
Yes, this is the law of sines.
Okay.
I love it. And the law of cosines, so the law of sines only has sines in it, and the law of cosines only has a cosine in it. So they're easy to kind of keep apart, and we'll talk about when do I use which? Is there a specific instance? Yes. The beautiful thing is everywhere that law of sines doesn't work, law of cosines works, and vice versa. So if one is not going to work in a situation, the other one has to. They kind of work together. It's nice. Now, we're not talking about law of cosines yet. That's the next section. But before I leave this picture, can somebody just tell me what's the area of this triangle? What's the formula for the area of a triangle?
One half base times height?
Yes, 1/2. The base is c times the height. So 1/2 ch. Do you guys notice that means, what was the height? I shouldn't have erased it, but the height was, for example, b sine a, right? Do you guys remember that? The height was b times sine a, or the height was, where am I at? A times sine b. So I can rewrite this as h is b sine a. So this will be 1/2 bc, Jeff, sine a, or I can rewrite h as a sine b. So this will be 1/2 ab sine c. Jeff, you could do it. 1/2 ac sine b. There we go, buddy. Now watch this. This is kind of cool. Make sure I got all that in there. Yes, AC. Okay, good. This is really pretty cool. Any triangle you see, if you know two sides in the included angle, you can see what I mean? AC includes B. AC includes B. B is in the middle of the two. Then the area is 1/2 multiply the sides times the sine of the angle. That's true for all triangles everywhere. Now you do have to know an angle and two sides. That's all you need to know, and you can figure out the area of any triangle if you know those things. Are you guys semi with me out there? No? And
I just missed the last part.
Say again, sorry?
You said if you know two sides in the included angle, area equals
the product of the two sides times the sine of the included angle. So if I knew A and C, I could use B as the angle. If I knew B and C, I could use A as the angle. And of course, if I knew A and B, I can use sine. I'm sorry, C as the angle. So that I've written what looks like several equations. These are all the same equation. The area is 1/2 multiply two sides times the sine of the included angle. So it doesn't matter which side you know, as long as you know the angle between them, you can get the area. Okay, all right, maybe. So I just wanted to get that out there before I erased all these beautiful pictures. Let's see what time is it. Okay, so let's do one example using law of sines. And I've got this cool thing I've got set up. Let's not do that one yet. That one gets a little freaky. All right, you guys ready? I'm gonna erase all this. Okay. Let me see. What's a good? I don't want to do the freaky type yet. So let's do. Let me get a decent little example. Oh yeah, that'll work. Okay. So here's a big thing about this. So let's see. Let's make this. All right. Let's see. Sure. Sure. Okay. Yeah. Now, the really nice thing about identifying when you can use law of sines is, can you make a complete ratio? Can you make it? You don't have to use all of these three at the same time. In fact, don't. That gets really weird. Is there a complete ratio that you can make? Does everybody understand what I mean? Do I have an angle with its side? Can I do that? Do I have an angle and its side? Do you understand what I mean by that? Where's angle C in this thing? What is angle C? This is angle B. This is angle A. So that's angle C. Everybody with me? Do you know side C?
10.
Yes. So I can make a complete ratio, can't I? I know an angle and I know its side across from it. So sine of 52 divided by 10. Now, which pair can I not use at all at first? Which pair, angle and side, do I not know shit about? Obviously the B's. But this one, I know the angle is 29. And I know this, and I don't know the side, but now can I solve for the side? That's how you use law of sines. It's relatively straightforward. How do I know when I can use law of sines? I can use law of sines if I can create a complete ratio, because then I'm guaranteed to have just one letter that I don't know. How do I solve this for A? You could cross multiply. You could flip sides and then multiply by sine 29. There's a few different ways to look at this, but you should end up with equals 10 29 divided by sine 52. All right, let's see what that is. Oh, what mode am I in? Okay, good. Let me know if you guys get an answer.
$6.15.
Yes, that's what I get, 6.15. So that's what that side is. What is angle B? I could have done this, but oh well. But what is angle B? How many total degrees in a triangle?
99 degrees.
Oh, sorry. Oh,
Angle B is 99 degrees.
99, because you have, so far you got 81, you need 180, so 99 degrees, I like it. So now I can set up sine 99 to B equals sine 52 to 10, and then I can solve for B the same way I solved for A. Now, real quick, which side should be the longest? Maybe I've drawn this out of scale.
C.
Why should B be the longest side?
Oh, because it's facing the biggest angle?
Yeah, it's got the biggest freaking mouth, so I can fit the biggest stick in there, right? I'm a complete nerd. I always think about that scene in Star Wars where he sticks the stick in the Rancor's mouth, big ass mouth. So the bigger the mouth, the bigger the stick I need. So of course this is going to be biggest side because it's across from the biggest mouth. So let's see if that comes out to be true. If I do the same thing here, B will equal 10 sine 99 divided by sine 52. Yeah. Somebody else, what do you get when you do that? Somebody else, anybody out there?
$12.5?
Say again, sir.
12.5?
12.5, yeah, 12.5. 12.53, let's say. So I would tell you how far to go out. So 12.53, that exactly matches with what I expect. The smallest angle has the smallest side, middle, largest angle, largest side. Kickins the acid. Now watch. Last thing I want to leave you with. I think we'll head out early because today you guys are really freaking me out. I have set this up. Now look at this. I mean, come on. I did really good with what I got. I got a magnet. I chopped off a little piece of something, cardboard stuff. All right, now watch. All right, so what's going on here is I'm going to give us an angle. I had this figured out earlier. I had an actual problem. I'll screw it. I forgot what it was. Let's say this is what'd you do, Jeff? Let's do, this is 9. Let's say this is 39 degrees. Sure. And then this is 7. This is 7. Ship this little piece here. Ship. There we go. Now watch. No, stay with me. So I'm telling you how big this side is. I'm telling you what this angle is. Is everybody with me? I have no idea how long this side is, but I know it has to be right here. So the angle is 39 degrees. Check. And I'm telling you how long this side is. Now watch, here's the weird thing. So I'm basically telling you, now watch this. This is kind of beautiful. Angle, side, angle. Let me try this again. Angle, side, side. There it is. I'm telling you angle, side, side. Angle, side, side. So this is going to be the ass that makes things difficult for us, because watch what happens. Here's one possible answer. One possible answer looks like this. There's a triangle there, right? It's got the angle, it's got that, it's got this. Do you guys see why this is not an answer? Because does this make a triangle? No, so this obviously is an answer, correct? It makes a triangle. You guys kind of with me out there? But look, isn't this also a valid answer? This freaky ass little slivers triangle. Do you guys see what I'm saying? There are two possible triangles that meet the requirements. This angle, this length, I'm erasing my poor little angle, I'm sorry. And this length of a side. So what we're gonna see, let me see if I can, now watch this. Let me, here's the last thing we'll do. All right. We're not gonna do this all the way out. We're just gonna kind of get this started just to get your brains going. So let me identify some stuff here. Let's call this, it doesn't really matter, Jeff. We'll call this A, we'll call this B. So this is B, so this is C, this is C. All right, is everybody with me on this? So what's the complete ratio I can make? Is right here, correct? So that would be sine 39 divided by 7 equals, now the other one I've got to use is this one. That's the other one that I know something about. Sine A over 9. I really hope I remember. I think I did this right. Okay. I was trying to figure it out earlier to make this actually have an answer. How the hell do you solve this? What do you have to do eventually to solve this? I can multiply 9 up here, right? But then how do I solve for A? What do I do? How do I solve for A? What do I have to do? How do I solve for A? What do I have to do? What do I have to kill to get A by itself?
Sine.
Sine. Good. Now, please, dear God, nobody tell me to divide by sine. That'll make me go a little insane. It's sort of like, how do you solve this equation? Well, you divide by square root symbol, Jeff, of course. Holy shit. How do you kill the sine correctly? What do you do to both sides?
Inverse.
Inverse sine. So if I do the inverse sine of this, that cancels. And then I got to do the inverse sine of this. So if I were you, this is exactly what I put in my calculator. Inverse sine of 9 times this divided by this. Do it all at once. All right. Are you guys able to do that in your calculator? Let me know if you can't. Let me know if you don't get the answer I'm going to write up here. Is somebody able to get that answer? Give me 2 decimal places. Oh, there we go. I see it in the chat. Good. 54.01 degrees. Now, if I go with this, look, I'm going to put a little 1 here. And you'll see why here in a minute. That's one option. What would B be? B1. If A is 54, what would B be? B be? What would B be? Anybody?
$86.99.
Yes, 86.99. How'd you figure that out? Because it's freaking 180 total, so that's not hard. I like it. Oh, I see it in the chat too. Sorry. Now watch. Now watch. Stay with me. Stay with me. This is so cool. Here's the thing. This is kind of funny. This is the one place where sine is also an asshole. Okay, this is why it's kind of sucks. So too bad for me. Inverse sine. Remember, inverse sines outputs are between negative pi over 2 and pi over 2. Correct? Therefore, the output could be a reference angle. And that could mean there's another triangle possible. So if I do this, then this is A, what is this? I mean, this is a 54.01. What would this be? Wouldn't that be 180 minus this? So what is the other possibility for A? What's 180 minus this? Yes, 125.99 degrees. Does that leave something for there to be a B? If A was 54.01, B would be 86.99. If A was 125.99, is there a possible B? Is there stuff left over for B? Does anyone understand what I mean? What's 125.99 plus 39? That leaves stuff over for B, doesn't it? There's a possibility for another triangle. Right, 125.99 plus 39 is 164.99, which means B2 could be 15.01, I think. Did I do that right? Somebody help me out.
Yeah.
Seems right. Yes? Okay. I have no idea if you guys understand what's happening. This is the visual of why there's two possible answers. Here's one possible answer, but then inverse sine could actually be a reference angle, and it actually wants to mean this. Now, sometimes you'll do this, and this will be too big, and there won't be another B possible. Thank God, that means there's no second triangle. There's not always going to be a second triangle possible, but there could be. In this case, there is. So I would have to keep going. I know the angles now. Now I'd have to figure out the one last side in this case. I have to figure out what little b1 is, and I have to figure out what little b1 is in this case. And then I would have the complete solution for the triangle. All right, that was a lot to throw at you at the end there. But that's plenty, I think, for today. I think we can stop there. Especially because you guys are sort of half here, but maybe tomorrow more of you will be fully here with questions. We'll do more examples of this. We'll talk about law of cosines, which is exciting. It's the extension of Pythagorean theorem. Very nifty. But otherwise, that's enough for tonight. So let me know if you need to hang out for a little bit, if you have any questions. Otherwise, you are free to go. Get some sleep.
I have a question.
Yes.
How did you know A2? Angle A2?
Oh, so it's the reference angle. This is a reference angle. What is the angle it's actually talking about? So just do 180 minus that.
Okay.
Because again, does this make sense that, all right, this is A. If I swing it, this is now 54.01. So what is inside the triangle will be 180 minus that.
Why is gonna be A?
What do you mean? Sorry.
Why does
Because this is really neat. Let me draw this in. What kind of triangle is this? Isn't it a isosceles triangle? Because isn't this side? Well, shit, what's happened to me? Let me take this away. Isn't this side the same length as this side?
Yes.
It's the same. So isn't it isosceles? So wouldn't this angle be the same as this one?
Oh, I see. Yeah.
Because I have an isosceles triangle. So then what would this angle be? It would be 180 minus whatever that one was.
Okay.
Yep.
Thank you.
So that's just the idea of inverse sine could give me an angle that's a reference angle. Does that make sense? And that's what I do with the reference angle, is do 180 minus that to get what that real angle is.
So you said that happens only for sine, no cosine?
Yeah, cosine, inverse cosine goes from 0 to 180.
Yeah.
So therefore, inverse cosine is going to cover all the possible angles for a triangle. So the law of cosines does not have any situations where there's two possible triangles. The law of sines has a situation where there's two possible triangles. And it's because of the output for the inverse sine versus the output for the inverse cosine. Inverse cosine covers 0 to 180. That's all the possible angles a triangle could be. There's no reference angle weirdness.
Right. 0 to 180.
Yeah, inverse cosine output is 0 to 180. Or 0 to pi. Okay.
Thank you.
Sure. All right, let's see. Charles, Isabel, Kirk, Connor, Julius, you guys okay?
I don't understand 3B on the quiz.
All right, let me see. Let me look yours up here. Here we go. All right.